Hello, my name is Ted Ground. Uh, I'm a fifth generation Texan. My ancestors settled in Texas in April of 1848. This is my first attempt at doing a YouTube channel, so I hope you have a little bit of patience with me. Um, I have a degree in biology from UT Austin and aquatic biology at Texas State University. And starting in about September of 2014, I started writing technical solutions for innocentive challenges. Um, and you can look innocentive up. It's a pretty cool thing. But I discovered it. You might say that I was recruited to this innocentive platform by roving curiosity. The first problem that I ever tackled was the Mars Balance Mass Challenge. The idea for a solution that I had struck me just about immediately with some help from watching the clouds at sunset. I sat at my computer, on my keyboard, on a workbench and a makeshift desk in the laundry room of my brother's farmhouse near Rising Star, Texas, where I happened to be living at the time for several years. It was a good place to think and to write. In about a week, I had it written up with cited references and drafted graphics to illustrate my idea. I think that solitude helped fuel and feed my uh, solitary march, a kind of a party of one and a Lone Star R&D think tank. Over the next year, I would write 68 of my ideas there at that simple desk made of painted plywood and lumber. It would be months before I was notified about NASA's evaluations. In the meantime, I pressed on, trying my hand at nine other challenges, despite having learned nothing about winning or losing the NASA challenge, which was my first one. Uh, I have no clue, really, what motivated me to continue writing, except that engaging in these pastimes was sort of its own reward. So later that year, I won my first award for identifying novel sources of trace minerals. It was totally unexpected news. It was great to win an award of $5,000 out of a $7,000 prize pool. I had won first place. So Merry Christmas. It encouraged me to continue to enter these other challenges and when and if I could, these other challenges that I felt comfortable enough trying to compose ideas for. Later, that would change as I tried my hand at composing ideas that pushed the envelope of my comfort zone. Then, in early January of I think it was 2015, I was very surprised to read or to receive this email. And it was from Innocentive. It said, "Dear Ted, it gives me great pleasure to let you know that the seeker's review of your submission to Innocentive Challenge, NASA's Balance Mass Challenge, using dead weight on Mars spacecraft to advance science and technology, led to a favorable evaluation. You will be awarded a total of $20,000. The seeker has provided you with the following feedback. This submission is an extremely well thought out concept with very creative use of the balance mass devices, which would meet technical requirements. Good use of citations and historical comparison to sounding rocket investigations. What made the submission stand out was its simplicity and practicality with a potentially high yield in scientific knowledge. Little to no modification of the Mars Science Laboratory re-entry system would be required. Concept warrants further investigation into the availability of orbital and ground assets and feasibility of obtaining the desired data on the release of barium and or other tracer elements. It is the opinion of the Balanced Challenge review team that this challenge clearly stood out from the rest of the submissions and has been approved for the full $20,000 award. Congratulations for the creative thinking and useful solutions. So a little later in 2015, it was May of 2015, NASA said, hey, would you like to give a presentation for us at the Jet Propulsion Laboratory in Pasadena, California? And I said, okay, sure. I was a bit anxious about that, but it turned out to be pretty good. There were some great people at both NASA and JPL that helped me feel more at ease in talking to all these, rocket scientists and engineers and so forth. So I was invited to give a presentation to the scientists and engineers at JPL in Pasadena, California in May of 2015. I think it was May 14th. I had hoped that my solution would have been used for the next NASA rover mission to land on Mars that was called Perseverance, as you may remember that. At the time that this book, One Smart Crowd, came out, it was scheduled to land on Mars on February 18th of 2001, although it seemed to have been favorably welcomed at the presentation that I gave at the Jet Propulsion Laboratory. Unfortunately, it was not included in that Perseverance mission. I do try to follow news of that mission closely. I think it's brilliant, and perhaps there's still hope that some version of my idea will be used in other future missions to Mars, or maybe even to Titan, since that moon of Saturn also has an atmosphere that calls for further observation and study. Anyway, I hope so, for even more fun and novelty to help pass our time with. It was only a little later that I learned that there were 2,138 active solvers for that Mars Balance Mass challenge. There were 219 proposals submitted from 43 countries. So I was really surprised, very surprised, that I won first place or any award with that level of competition. So one interesting thing to me is that many of my ideas existed in some form before I ever learned or read about a particular challenge. I have won about 102, or actually I've written 102 challenges through InnoCentive, and won about 24, which is, it's pretty good. So, for example, I've often wondered or daydreamed about the atmosphere of Mars, or what polymers and composites could be made by in situ resource utilization, that's called ISRU, of materials available on Mars. And I've often wondered about finding better, more efficient, and less costly ways to desalinate water to help reverse desertification right here on good old Mother Earth. Sometimes it takes a challenge to come along and offer a game prize, an incentive to, polish up, formalize, and articulate old antique ideas that I may have pondered, but were sort of put on the shelf, if you will, years before. So what you're looking at here is the slide deck that I used back in 2015 to talk to NASA and JPL. And they wanted to know a little bit about me personally. What uh, what made me curious about doing these sort of things. And since I was a kid, I mean, I've been interested in science, astronomy. Always talked to my dad about other stars. We'd go out and we'd look up at the sky and see the stars, and he told me that all of those are actually suns, just like our sun, but they're far, far away. And I said something like, "Well, Daddy," and I mean, I don't know, three years old or whatever. And I said, "Daddy, there couldn't be an end to the universe because what would be uh, on the other side of that brick wall?" Something like that. I remember having this conversation, and I had a chemistry kit that they gave me where I could take and put different minerals uh, or materials into a flame, and you'd have these different emissions. There would be different uh, spectra from different metals. And that's always kind of been with me. I've been a laboratory manager for a couple of laboratories in my career. I don't do that anymore, but anyway, it was fun doing that. But when I started thinking about this idea about how could you use the mass, the balance mass of the Mars uh, entry vehicle, and I thought, well, you've got this high energy environment. It's like 13,400 miles an hour, and if you ejected some barium, then it would ionize, going into the atmosphere of Mars, and you could look up from the surface or look uh, uh, into how that would ionize. You know that Mars doesn't have much of um, an ionosphere or a magnetic field as much as Earth does, but it's kind of spotty, and it would be interesting to learn about it. So that was one of the things that sort of influenced me. I looked up at the sunset and I said, maybe we could do it this way. Now this shows a cool sort of a timeline of the entry, descent, um, and landing stages for the Mars rovers. And what it shows is that the balance mass is ejected for a purpose. It changes the center of gravity of that capsule to make it, enter the atmosphere at the right angle. Okay, so you want that, and so NASA was saying, well, what could we use this dead weight for? Could it be used for something else? And that's where that occurred to me. And to me, it was like this was obvious. You didn't have to have high tech in order to do it. It was just eject the weight, and it would enter into the atmosphere, and it would leave a kind of a plasma trail or ionized barium or strontium or lithium that could be studied, and so NASA seemed to like that. So by the time I had given the presentation in May of 2015, I had won several other incentive challenges, including the NASA Balance Mass Challenge. And even since then, um, I've tried my hand at a number of these, and I've won about 24 of them. I've written, I think, 102. So it's not a bad batting average, and I really appreciate Innocentive for what they do, and I got to give them kudos for that. It was a fun thing and a helpful thing for me. Another thing I threw in as just an idea was to use methane canisters to drop into the atmosphere so that we could look at how methane um, degrades through UV light and chemical reactions in the atmosphere. We know that methane uh, comes out of Mars from various sources, and that it doesn't really last that very long. It doesn't have a very long half-life, if you will, because of UV light and so forth. So this could be another way to study what actually happens to methane that is released from the subsurface, probably, of Mars. I don't know whether NASA really likes this idea or not, but that's okay. This is a little bit more about the graphics of methane. This has been discovered through telescopes remotely to give you an idea that there's definitely some sort of methane generation process going on. We don't know whether it's biology or what it might be, but having a methane tracer in the descent vehicles might be a way to kind of model what's going on chemically with methane released from the subsurface of Mars. So probably biology, in my opinion, but we have to be careful in what we assume. It only took me about a week to draw this thing up and write about it, and I happen to have some help from Google SketchUp, which helps me to visualize all kinds of things, and this was one of them. And so this is the mass ejection thing made out of tungsten, but if you carve channels into it and you put barium in it, it wouldn't change the mass or the volume that much, and it would be a thingamabob that does the job, so to speak. Um, and all you'd have to have is a burstable membrane or a diaphragm or something like that. It would just open up and expose the barium to the 13,400 mile an hour reentry speed, which would generate the plasma that you're looking for to look and see what kind of ionization and magnetic field influence you know that might happen there. This has to do with my aspirations for hopefully SpaceX going to Deimos first and using the boring machine technology to form a subsurface uh, space station in Deimos. I think it's the perfect arrangement for us to go to Mars, but have a staging area at Deimos. So I've got a little Texas flag here. Hey, thanks for listening. If you have any questions or comments, you can, I guess, put them on this channel. I'm new to this, so I don't know exactly how to do it. I don't really, uh, I'm not really entertaining offers of employment right now. at my advanced stage, but this is a picture of the, some of the beautiful sunsets that we have out here, and what really got me thinking about this sort of thing. So, if you have any questions, comments, just let me know. Well, in December of, gosh, I guess it was 2020. Yeah, December 2020, Simon Hill and Alpheus Bingham, uh, who were the head honchos at Incentive, decided to uh, write a book called One Smart Crowd, and they asked me, could I take uh, my story and tell them about the background story, and so I did that, and that's if you want to check it out, it's in chapter 9 of the book. It's just me talking about what I was thinking about, and then later, in a few years later, they awarded me the Super Solver Award, which I was surprised. I was shocked, really, quite frankly. And so I have this little trophy, and I've got some other things I want to do on this YouTube channel, and that includes promoting this idea that I have for a fusion reactor. And y'all can pick it apart and think about it, whatever. But also some um, heat shielding for the Starship, and a few other things. So I guess before I ride off into the sunset, then maybe I'll just share it with y'all and see what you think about it. All right, cool.